Now let's talk about another conic section, hyperbola. Hyperbola is a conic section where eccentricity is greater than 1. And we get hyperbola by cutting triangle cones axially. We call it nipples, so that we have two shapes similar in this form. Hyperbola is very similar to ellipse in equation, but similar to parabola in shape. There is one specific thing about hyperbola. The distances of any point from the two focal points, the difference of the distance is constant, equals to 2a. Like this one now, f2p minus f1p is equal to 2a. We shall prove that one later on. But that's just a fact about hyperbola. So that when you are handling any question, if you are given a distance of a point from the first focal point, you can get the other one. But if it is parabola, ellipse, the sum of the distances from the focus will be equal to 2a, where a is the point of the vertex, the vertices. Now, since we have gotten these facts known already, let's derive the equations. Hyperbola and ellipse are similar in formula, but I derive it here. We have known that in this instance, e is greater than 1. And you can see the shape. And this serves as a line for symmetry. And this one too. So we have this point at 0, 0. This is our D. This is directrix. Same with this one. And then we will now do just like we did for ellipse. We will try to find the relationship between A, C, and D. That was the first thing. So it's -2. Now let's go. The distance of this place to this place is C minus A. And the distance of this place to this place is C minus D. This is our point of reference, our datum, point of reference. So, let's see. F1, let's call this place A, or V, yeah, or rather V1, V2. F1, V1 over F1, V1. You know, D1 is a line, straight line. So we are talking about the perpendicular distance. Please. Is equal to E. Same thing goes here. Let's talk about the distance of this place to this place. And okay, the distance of this place to this place, and the distance of this place to this place. So this one is V2. So let's see. F1 V2 over D1 V2. No, this one is supposed to be V1 D1. V1 D1, please. Is the distance of this place to this place. Now, let's break it down. What is F1 V1? F1 V1 is C minus A. V1 D1 is A minus D. Therefore, C minus A equals to EA minus ED. Now let's look at the second one. We have this place as minus A. So F1 V2 will be C plus A. D1 V2 will be D. Therefore, we are going to have C plus A equals to EA plus ED. Now, let's add the first and second equation together. We have 2C equals 2EA. Therefore, C is equal to EA. Please, that is very important. C equals EA. Also, let's subtract the first equation from the second one. So we are going to have 2A is equal to 2ED. So D will be equal to A over E. Another one. A over E. Now, just like the other one, our B, being that C is greater than A now, our B squared will be equal to, our B squared will be equal to C squared minus A squared. And by the time you look at it, you will see that B squared is equal to A squared into E squared minus 1. So you can see the similarity. You can see the similarity between the ellipse and the hyperbola equation. So we are going to get the equation now. Now let's work on deriving the equation. I have brought just one half of it for the derivation of the equation now. We have a point P with coordinate x, y, and we have D here. So the point at which the perpendicular will meet here will be dy. So the distance of P from F1 will be x minus c squared plus y minus 0 squared. And it will be equal to E. What is the distance of this place to this place? They are the same height, so it will be ED. You can see ED. So let's square both sides. Sorry, it will be E x minus D. X minus D. So this should be EX minus ED. Now let's square both sides. We are going to have x minus c squared plus y squared is equal to EX minus ED squared. So you can see the derivation is very similar to, so that's why I won't repeat so many derivation of formulas again in this place. Now you have x minus c and this one now. Let's subtract x minus c from both sides. We have y squared equals EX minus ED squared minus x minus c squared. And we know one thing, our D is A over E, so this place will become A, and our C is EA, so we are going to have EX minus A squared minus x minus AE squared. Now let's use difference of two squares in this instance. So y squared will be equal to EX plus x minus A minus AE into EX minus x minus A plus AE. So this is going to give x into e plus 1 minus a into e plus 1 is the same thing. This one comes to the front. In this instance too, we are going to have x into e minus 1 minus a, no, plus a, yeah, into e minus 1. So if we move this one to this side, so it will be the same thing. So we are going to have x minus a into e plus 1 into x plus a into e minus 1. So if we multiply this one and this one, it's going to give us e squared minus 1. This one and this one is going to give us s squared minus a squared. So we are going to have y squared equals e squared minus 1 over x squared minus a squared. So we are going to have y squared over e squared minus 1 is equal to x squared minus a squared. So let's add a squared to both sides and subtract y squared from both sides. So we are going to have something like this. A squared equals x squared minus y squared over e squared minus 1. Let's divide through by a. We are going to have 1 equals x squared over a squared minus y squared over a squared into e squared minus 1. So at the end of the day, our formula is going to be x squared over a squared minus, it says something about this one, b squared into a squared is a squared into e squared minus 1. So we are going to have y squared over b squared is equal to 1. That's the formula for hyperbola. Now let us see if the center is moved away from 0, 0, and we have it to be h k, the center here, the reference point. This place will be h plus d, and this one will be k, h plus dk. This place will be h plus c, k, and this place will be h plus a. We know what c is, we know what d is. So at the end of the day, if the reference point, the midpoint between the first hyperbola and the second hyperbola is hk, our equation will later become x minus h all squared over a squared plus y minus this hyperbola, please, minus y minus k all squared over b squared is equal to 1. By the time I start dissecting it, it will be the same way as we did in ellipse, so I don't want to waste our time. So this is what we have. That is for when the center or reference point is hk. hk. Please, I always advise that when we are doing this, we have our pen and paper with us so that we can jot some things or look to correct any error if possible. Now, let's go to the calculation of the formula, derivation of the formula for the tangents. Now, when we have the equation x squared over a squared minus y squared over b squared equals 1, I want to find the tangent to the hyperbola at points x1, y1. So we use calculus as normal thing to do. Now we have 2x over a squared minus 2y dy dx over b squared equals to 0. Now, dy dx is equal to n will be equal to minus 2x over a squared times b squared over minus 2y. So this will cancel this, and we are going to have b squared x over a squared y. This one is positive, please. So at points x1, y1, our gradient will be b squared x1 over a squared y1. And you know, the tangent equation will be something like this: y minus y1 over x minus x1 is equal to n. Therefore, we have y minus y1 is equal to nx minus nx1. So, let's make it like this: y minus nx equals y1 minus nx1. Now, looking at this, from this equation, we see that our y1 is equal to b squared x1 over a squared n. And we also know one thing, that our x1 over minus y1 squared over b squared is equal to 1. So, here now, in our gradient equation, this one here, we can say y minus m. Okay, let me go straight. That's another one. I can just say y minus y1 is equal to m into x minus x1. So, straight away, I know what xm is. So, y minus y1 is equal to b squared x1 over a squared y1 into x minus x1. So let me multiply this place through. It is going to give me a squared into y1 minus y1 squared is equal to b squared into x1 minus x1 squared. Now let me subtract. Let me add x1 squared. Okay, let's divide 2 by a squared b squared. Let's divide 2 by a squared b squared. That is going to give me y1 over b squared minus y1 squared over b squared is equal to x1 over a squared minus x1 squared over a squared. So let me add x1 squared to both sides and subtract y1 from both sides. So I'm going to have x1 squared over a squared minus y1 squared over b squared is equal to x1 over a squared minus y1 over b squared. Please, I want to view that. Now this is very similar to ellipse. The only thing is that there are just some sign changes because of the sign in the middle. Now, you know that x1 squared over a squared minus y1 squared over b squared is equal to 1. Therefore, the tangent equation is going to be x1 over a squared minus y1 over b squared. So that will be equals 1. Now, if the center moves to xy, and our equation becomes x minus h squared over a squared minus y minus k squared over b squared equals to 1. So our tangent equation, just like I have been told before, from observation and from proving facts, from proving formula, which we can also do. We have done that similar thing in ellipse. Will be at x1 y1 will now be x1 minus h into x minus h over a squared minus y1 minus k into y minus k over b squared is equal to 1. Is equal to 1. Is equal to 1. So that is how it goes. There are so many other questions. So when you get to the question and answer section, we still prove some other ones. But these are the basic things here. Basic things. And there are some applications also, even in physical world, of all these formulas. So it's very good and it helps to analyze so many situations. So let's look at what to look out for whenever we want to solve our questions. When we have any question, let's talk about parabola, ellipse, hyperbola. You know, this one, you can only talk of one focus. And what we look out for is the vertex given. Is it 0, 0 or another value like hk? So that is one thing. The next thing you look out for is what is the value of a if you are given? What is the value of a if you are given? And from there you can easily work out your formula. Just say, since you are given this, you just be able to say y minus k squared is equal to 4a into x minus h. So if your k is 0, you know what this will be. If your h is 0, you know what this one will be. And this one too can be like this. So it will just be x squared or x minus h squared is equal to 4a y minus k. So once you look, what you look out for is this point. Is this point given? Is the a given? And then you search for any other thing you can. Now let's look at ellipse. Ellipse, as a matter of fact, we have two foci. What do you look out for here? What is the center between the two focus? If you are given the two focus, or if you are given the two vertex, what is the center? That will be your HK. So once you can get this one now, you'll be able to say, and you know what your A is, you know what your B is, or you know what your E eccentricity is. You know, E for this one is 1, so they don't need to give you anything. So once you are given, even if you are given two different questions, they said one is E for one is, you know, value given is less than 1. You should know that one is ellipse. E for another one is above 1. You know that one is hyperbola. So since you have known this, you'll be able to say x minus h over a squared plus y minus k squared over b squared is equal to 1. So if your k is 0, if your h is 0, just know. So it's good you are familiar with this equation more than the other one. So this one too can be like this. So what you consider here, you know, I told you, the vertex is what you consider here. What is paramount to you here is this point, the midpoint. Now, so for this one too, it will be y minus k squared over, you know, the b has gone up there, plus, let's make that one a squared, x minus h over b squared is equal to 1. I know what b is. Your b squared is equal to a squared into 1 minus e squared. Now let's look at hyperbola. You have this. Once you know these points and these points, this is the point you look at for here. Please. The midpoint between the two vertices, or the midpoint between the two foci. Those are the main things you look at for there. So let's call this one HK. And from there, you just input your values. You know what your directrix will be from here. And then just say x minus h squared over a squared plus y minus k squared over b squared is equal to 1. So it can also be in this form too. It can go up as well. So that is the major thing. I still talk about some little things you need to know, but those ones are not hard. Now, they might give you the gradient at a point and ask you, find the equation at the points where gradient is m. With that, you can easily solve it. When you get your gradient, you can get y from there and then get x. You can get x, then get y. And sometimes they might want you to even get the equation without using x or y. Everything is possible. You just substitute and use your equation. We'll get into that in solution of problems. I would like to talk about two things. One, for hyperbola alone. For hyperbola, we have two like this. And we have A and B. So, the line y equals to b over a is asymptotes to the curve. That is, the curve will go and touch it at infinity. How do we get that? Know that x squared over a squared minus y squared over b squared equals to 1. When x tends to infinity, let's look at what y will be. 1 plus y squared over b squared. So when x tends to infinity, y2, so at that point, you can say that x squared over a squared will be equal to y squared over b squared, because the two of them will be infinity at a very large value. So we can say that x squared root of this one, that is x over a, plus or minus. So y x like this at infinity. So they are going to touch at infinity. You know that's what asymptote is like. That is, it's going to touch it at very large value. So we have this as our asymptotes. This is another thing they can use in solving hyperbola. So, you know, at this point, if this is A, this place too will be B. As this place. So you can see. So we have B, that is Y, you understand? So the line x, y equals to plus or minus b over a is asymptote to this. Another interesting part of this conic section is a chord we call lattice vector. Lattice vector. What do you mean by this? It's a chord that passes through the focus and touches the chord. It cuts the chord, passing through the what's it called? Focus perpendicularly or parallel to the directrix. So let's look at this one. If this is a parabola, you know that for this part, y squared is equal to. Now let's talk about the lattice vector. Lattice vector is the distance between the curve along the curve. The distance from where the chord passes through the focus. So that is the lattice vector. The chord that passes through the focus, parallel to the directrix. So let's look at the lattice vector for parabola. You know, for parabola, the directrix is at the tip here, A, 0, 0, and the focus is at A, 0. But the formula for the curve, for the locus of the curve is y squared equals to 4ax. The focus is at the point A. So y squared equals to 4a times a, which is 4a squared. So y for this point is y equals to 2a plus or minus. Then you find the square root of this. So we have 2a here and minus 2a here. So that's the point at which the chord that passes through the focus we touch the curve. So what is the length of this? The length of the lattice vector is equal to 2a minus 2a, which equals 4a. So all these things I'm just telling you because it's very easy to derive. Now let's look at that of the ellipse. You know, for ellipse, we have the directrix outside. Yes, so we have the focus. Our focus in this place is AE. AE. Note. So the lattice vector will pass through like this. And this is our center, 0, 0. To find the length, we use the formula. What is our formula? X squared over a squared plus b squared plus y squared over b squared is equal to 1. Then, what is our point? Our x-axis of the lattice vector. You know, this is this. So we have AE. So we have AE all squared over a squared plus y squared over b squared is equal to 1. So let's cut it. So we have y squared over b squared is equal to 1 minus e squared. But please recall, for ellipse, that b squared is equal to a squared into 1 minus e squared. Therefore, 1 minus e squared is equal to b squared over a squared. Therefore, our y squared is equal to b squared times b squared over a squared. U is equal to b raised to power 4 over a squared. So our y axis for the points for x equals to a is going to be plus or minus b squared over a. So the length of the lattice vector is going to be b squared over a minus b squared over a, which should be equal to 2b squared over a. That is for ellipse. Now let's look for that of hyperbola. For hyperbola, our formula is, this is how hyperbola will look like. This is the directrix. So this will be a, this will be ae, this will be a over e, this will be oo. So the lattice vector will cross like this. So we have x squared over a squared minus y squared over b squared is equal to 1. Therefore, the y-axis at this point, we are going to get like this: ae squared over a squared minus y squared over b squared is equal to 1. So we cancel this. So we can see that minus y squared over b squared is equal to 1 minus e squared. Let's multiply both sides by minus 1. So we are going to have y squared over b squared is equal to e squared minus 1. But for hyperbola now, b squared is equal to a squared into e squared minus 1. E is greater than 1. So e squared minus 1 is equal to b squared over a squared. Therefore, y squared over b squared is equal to b squared over a squared. So y squared equals to b raised to power 4 over a squared. So y is equal to plus or minus b squared over a. So this point will be plus b squared over a minus b squared over a. So what is the distance now? The length of lattice vector will be equal to b squared over a minus b squared over a, which is equal to 2b squared over a. So with all this, we can do many things, and in the question and answer, we'll be able to solve some things. And if you have any question to ask, you are welcome. And thanks to those who have been supporting, who have been encouraging and advising. I appreciate everything. Please kindly subscribe, comment, share, and tell others about the good work we are doing here. Thank you very much.